welcome to our session on creating and securing connected and trustworthy IoT devices. My name is Joseph Lloyd. I'm a technical program manager with the Azure Sphere product. Joining me today is my colleagues and friends Chirag, Shah, and Dave Glover. And we'll be talking through a couple of really interesting things about what Azure Sphere can do for IoT and for connected devices. So if you're going to be bringing an IoT solution to the market, there are a bunch of different things that you can build to help enable that IoT solution to be successful. For example, for each device, you can choose a specific silicon and that's associated with a board support platform, an operating system, the ability to connect securely, TLS, sessions to encrypt those connections, and certificates to manage those encrypted connections and manage the device identity. You can work with TPMs on that device or other tools to be able to have identity fixed at a per device level. And stepping beyond the device, there's a bunch of different capabilities that you can build into the cloud side to make your IoT solution really shine. Doing PKI to manage that identity, having cloud services backing the configuration control of those, the ability to have an operations management interface and over-the-air update to keep these systems up to date or to push new features to customers or to the field. These types of things are all instrumental in enabling an IoT solution to really succeed. And on top of that all is really your application, the thing that you want to accomplish for your specific business value. The thing about Azure Sphere is that we enable almost all of this stack so that you can focus on your application. And so a single silicon, an operating system integrated to that device, and cloud services are provided as the Azure Sphere solution, this three-part solution available at basically one cost, one interface to Microsoft to enable your application to succeed and so that you can focus on your business value. That gives you a lot of flexibility to really focus on what you can accomplish. Scenarios such as predictive maintenance, understanding your power consumption, identifying workplace safety concerns and mitigating those before they're actualized. Doing all of this capability at the edge reduces your total business cost associated with instrumenting your business. It reduces the latency of understanding this data, and it enables you to save energy across your product and portfolio, not just the IoT devices themselves, but what they're connected to. So there's some really interesting opportunities with Azure Sphere when it comes to AI at the edge. We're going to talk about Edge Impulse today, which is not a Microsoft product. It's a product that's available that's built with TensorFlow or TinyML to enable you to instrument and sense information at the edge, run an ML model, and be able to drive that to the cloud and create a solution all in one together. Now, Edge Impulse is designed so that you don't need to be a data scientist. So there's sort of prepackaged items that you can take and tailor to your application. So similar to how Azure Sphere is trying to solve the IoT connected device pattern, Edge Impulse is providing the ability to really enable you to succeed and focus on the specific things you're trying to measure, understand, or instrument at the edge. So joining me, we have a pre-recorded video from our friend Dave Glover, who's in the Australia time zone, which is not the most convenient for scheduling these conversations. And so I just want to introduce you to Dave. And this is a pretty cool thing that he's going to show off.
Hi there and welcome. My name is Dave Glover and I'm a cloud developer advocate based in Sydney, Australia, with a focus on secure IoT and AI. Now this demo is going to be all about using machine learning models for predictive maintenance running on Azure Sphere. Now all of the source code is available on my GitHub at the link below, and the developer board that I'm going to be using is the Avnet Azure Sphere Starter Kit. Now the advantage of this board is it has a built-in accelerometer. And that accelerometer is very useful for driving data for the machine learning model that I'm going to be using. Now, in my demo, I'm using a TinyML model built with Edge Impulse. Now, the Edge Impulse web portal makes it super easy to go and create TinyML models that target microcontrollers, including Azure Sphere. So in the screenshot, you can see I've got the new project wizard that focuses on common scenarios. So for example here, I could go and create a model based on accelerometer data that I could use for predicting machine failures or detecting human gestures. There's another wizard there for audio, training up audio models for things like wake-up words, as well as being able to go and train models for image classification and object detection. Okay, so this demo focuses on predictive maintenance for HVAC systems. So first I want to talk about the Azure Sphere. So the Azure Sphere is a multi-core microcontroller that you can deploy custom apps onto 3 cores. So we've got what's called the Cortex A7. And the Cortex A7 runs system services such as security services and over-the-air updates, as well as being able to deploy a custom high-level application that you would write. Now, there are also 2 real-time cores, which are called Cortex M4s, and you can run custom applications on those. So on the first core here, I'm going to be running the Edge Impulse Tiny machine learning live model for movement classification, which I'm going to use for predictive maintenance. Now, I could also run another application on the other Cortex M4, and that could also be another TinyML model. In this case, the example I've got here is hazardous fumes classification for a work safety solution. Now, on the cloud side, I'm going to be sending model predictions through to a solution called Azure IoT Central. And Azure IoT Central is an IoT web portal where you can chart data and define templates and forms and things like that, as well as being able to export data. And what I'm going to be doing is exporting the prediction from the Azure Sphere device all the way through IoT Central through a logic app workflow, and then ultimately to Microsoft Teams for collaboration and notification. Okay, so for the demo. So on my desktop here, I've got an Azure Sphere device, and it's the Avnet board, and it's got a built-in accelerometer. And on the left-hand side of my screen, I've got an output from the real-time core, which is running the TinyML model. And what you're seeing here is the current prediction. So at the moment, the device is not moving. So the model for the inference is saying, well, no, there's nothing happened. It's just running normal operation. Okay, so what I'm going to do now is going to pick up the device, and I'm going to shake the device a little bit, side to side. And you can see this is what I defined for when I trained the model. The side to side would be labeled rattle. So there is the HVAC in this case is rattling. Okay, so another gesture that I defined was, hopefully I can get it to come up, was for bearings. So this is one I defined for the bearings in the motor in an HVAC system, and in that case they were faulty, and you can see it showing up bearings. And you'll see, because I put the board back down, it's gone back to normal operation again. Okay, so what I'm going to do is I'm just going to go through a couple of apps, not in a huge amount of detail. So this first application here is the real-time core application, which is running on the Cortex M4, and it is responsible for running the classifier. So what it's doing, it's reading the data from the accelerometer, so the X, Y, Z coordinates, and then running that data through a model. And then ultimately what it's going to do is going to send that prediction through to the high-level application, which is then going to forward that or relay that on to IoT Central. Okay, so on the other app that's running on the Azure Sphere is the high-level application, which is effectively going to listen out for messages from the real-time core application, which is running the TinyML model, and it's going to relay that prediction to IoT Central. So what I'm going to do is I'm going to put a breakpoint in the code, and I'm going to pick up the Azure Sphere and then wiggle it side to side. and you'll see I get a rattle. If you look on the left-hand side, you'll see it's generated a rattle. And in fact, if I scroll down here for device output, the last prediction was indeed rattle. So what I'm going to do now is I'll step through the code, F10, and I'm going to update a device twin property in IoT Central. Press F5 to run that. And then you'll see the breakpoint's been hit again. That's because I've got a break. Another message has come through because the predictive fault for the device is now normal. And in fact, I don't send that message to IoT Central. I only send things that are faulty. Alrighty, so that's what's kind of going on the device. So I've got this real-time application, which is doing the inference, doing the predictions, and it's passing the prediction to the high-level core, and that application is then relaying that message or that prediction to IoT Central. Okay, so the next thing I'm going to talk about is IoT Central. And we'll come across here. So I'm going to choose what's called a template. And this one here, I'm interested in the predictive maintenance template. So any device that's in the predictive maintenance. And the device I got registered, there's only one in there, is the device that's on my desk, which is running this fake HVAC system. And the device is called HVAC system, and it's in the mayor's office for random reasons. And you can see this device has some metadata associated with it. So it's got a contact name, which is me, contact number, device location, and the device description. It's Contoso, and it's an HVAC Model B. Now, looking over here in the HVAC state, you'll see that the fault prediction is rattle. So that's kind of what the last known state, or the last known error state for this device, for this HVAC, was rattle. Now, what I'm going to do is I'm going to export this data through to a logic app. So I'm going to go look at my destinations, and I've got a destination already set up here called Predictive Maintenance Logic App, which is going to run my workflow. And what I've set up in a logic app, I've set up a webhook, and that's the URL for the webhook. So what's going to happen when a prediction comes through from the device, gets to IoT Central, this webhook is going to be called with the latest prediction. So go back to my destination, go to exports, and then this is my export for predictive maintenance. And then what this predictive maintenance export is, what this export is going to do, it's going to export all telemetry, or all properties in this case, for the device template predictive maintenance. And if I scroll down a bit further, you can see I've added in some additional properties for contact name, number, description, location, device name, and fault prediction. And then ultimately, the destination for this is going to be the logic app, that destination which I just showed you, which is predictive maintenance logic app. Okay, so the next thing I'm going to do is I'm going to go across to my logic app. So it's my Azure logic app, and this is my workflow. And I've got two operations in here. So the first operation is the HTTP webhook. And it will just listen out for requests that come in from IoT Central. And IoT Central will bundle the data packet on that webhook. And it'll hit that operation. And then what that operation does is it passes that message on to the Microsoft Teams operation. And if I go into the Teams operation, you can see that I'm going to post it into channel. The channel is classified demo, which is what I called the channel, and it's going to go into general. And you can see that I've created a template. This is a template message. In this case here, it's the HVAC maintenance. And you can see I'm passing in the variables or the data that was sent, that has been bundled up and sent from IoT Central over that webhook. So I've got the fault prediction, device name, description, contact name, number, etc. Okay, so what I'm going to do now, I'll just close it up, is I'm going to go over to the right-hand side. So you'll see on the right-hand side, I've got Microsoft Teams running. And you can see the last message here was 6:58 p.m. And what I'm going to do now is I'm going to pick up the Azure Sphere device on my desk, and I'm just going to shake it side to side to generate the rattle. Hopefully that's enough. Put it down. And you'll see that that's now generated a message which came through at 7:02, which, as you can see down there, is 7:02. I'll do see more, and you'll see that there goes my message. So I've got my HVAC maintenance alert. The fault prediction was a rattle, and you can see that this is the device name, and this is the information here for the engineer, and this is the contact name and the location for the HVAC unit. So you can kind of see what's going on there. So I've got this TinyML model that's running on the Azure Sphere. Remember, that's running on the real-time core. It's relaying that prediction across to the high-level core, which is then updating a property in IoT Central. IoT Central is at displaying that information. So if I pop over to IoT Central, so you can see in my devices, in predictive, there goes my device. So I can see that in IoT Central. Then you remember I exported that data to my Logic app, and then ultimately that information appeared out in Microsoft Teams. So hopefully you kind of get a bit of an idea of how this is all flowing. Okay, so just one more slide. So this is just the resources. So do check out Edge Impulse. They have a free developer offering as well as an enterprise offering. So at edgeimpulse.com. All the source code, and there's a wiki for this Azure Sphere classification for predictive maintenance. All the code is sitting up there on my GitHub. There's a couple of other scenarios which I thought might be interesting. There is a nice workplace safety scenario, which is using face detect on the device and then using the Face API in Azure for the cognitive services to identify who the person is. So quite useful for things like workplace safety. And the last one is just a demo which I just love. It's called the artificial nose. And in this case here, it's using a gas sensor. And you could use this to detect hazardous fumes in a workplace environment. So so kind of put that under industrial safety. So again, a really neat solution that can be easily ported across into Azure Sphere. Anyway, hopefully you enjoyed that, and enjoy the rest of the conference. Thank you very much.
So that was a really cool demo. We basically saw things working from device to the cloud being delivered in an actionable way. Now, because that's Azure Sphere, that wasn't just a hacked together demo on the back end. Instead, that was an end-to-end TLS encrypted set of communication for everything that you saw. The device that was being used for that demo had passed a full enterprise level attestation and authentication. It was given a certificate that was granted within 24 hours and was running an operating system that had the latest CVE patches and patches for security issues that had come up. That was production level communications capability with enterprise level security, all together in just that short area to demonstrate how you can go from from a dev kit and from the tooling provided by Microsoft Solutions here to something that is production worthy. So I'd like to introduce my colleague Chirag Shah. He's going to talk through some of our customer applications, and these are some really exciting things.
Thank you, Joseph. Appreciate that. And welcome, everyone. Thank you for your time today. My name is Chirag. I am a project manager with the Azure Sphere organization, and wanted to tell you a little bit more about how this solution is being used. You've heard a lot from Joseph about the value of having a solution that is fully integrated, where you are able to focus on the differentiating value that you provide instead of some of the more fundamental things about building an operating system, updating the operating system, finding and creating support for security in the platform, and integrating in various Azure components. Having all that done for you really allows you to focus on the value that only you can provide for your product and application. And so we've seen customers in the past year or so that Azure Sphere has been commercially available. We've seen customers use these in really two major types of operations. One is on the simple pieces of equipment, things where you may have initially looked at using a Raspberry Pi and producing a solution. And what we found from a lot of customers is, it's really nice to prototype with something like a Pi, but it's not commercial grade of something that, how are you going to go update that device? How do you make sure that that device is being patched? How do you make sure that that thing, it has enterprise grade security through and through the solution, and that your devices, as they are deployed, it's fine to have a device that's deployed and sitting on your desk, or one that is, down the hall from you. But when you have 1,000 of these, when you have 10,000 of these devices deployed geographically all over the world or all over a location, you really need something that you can trust and bring forward. And so we've seen people start with very simple projects where they might have used another simple development kit, and they've started to use that with Azure Sphere, because not only does it provide you with the development solution, it also provides you all the ingredients you need to make sure that device is built securely and stays secure and is easy to connect and integrate to the rest of the solution stack you need in the cloud. The other piece, because this is a platform that is, meets the same level of security standards and capabilities that all the other enterprise solutions use, from the Windows organization or from other elements that IT may have done evaluations on for the security standards and meeting the compliance standards that are necessary. Azure Sphere is being used by customers for those mission critical solutions. And we'll talk about that a little bit in the next couple of slides about some customers and what they've actually used. But we've seen common use cases from customers across a variety of industries, areas like smart spaces, manufacturing, energy, areas where there is critical infrastructure involved and that needs to be done in a reliable, secured, trusted way, so that you are not creating access points into your environment that have the potential of disrupting your operations. You don't want to go and, for the sake of trying to get data off of your device, you don't want to open yourself up to compromise for some vulnerability. And we've seen customers utilizing Azure Sphere in all of these solutions because of the security and the trust that it provides. We've seen customers use this for several key use cases. Predictive maintenance, that's something that you saw in the demo that Dave just showed. We've also seen this in areas like human and what we call cyber physical security, the connection between the physical world and the electronic world, where no longer does somebody actually turn a physical dial when they're working on a piece of equipment. Most of the times it's an electronic signal that's actually sending that dial forward. So we need to make sure that those systems are secure and protected, so that you don't have the risk of somebody infiltrating your network and then being able to change the behavior of the equipment that you're working with. You need to keep the equipment safe. You need to keep people safe. And then the last piece that we've seen a lot of activity on is on sustainability. And we see this both in terms of the usual things you would think about with sustainability around energy usage, natural resources, water consumption, and reducing those usages. But we've also seen it, especially with the COVID pandemic, around human productivity. You can have less people in an environment. It's harder to hire people to work in your environments and to get the labor you need. And so we've seen more and more companies using solutions like Azure Sphere in order to offset some of the manual work that was previously done by people and turning that into something that you can do automatically with devices. So why don't we move over and let me talk to you a little bit about the solutions that we've seen from some of our customers. So one of them is Welbilt. Welbilt is one of the leading producers of commercial kitchen equipment in the world. They are number 1 and 2 in all of the different product lines that they operate in. And so if you've gone to anything from a Burger King to a McDonald's or any other type of a fast casual or kitchen restaurants that you've encountered, Welbilt equipment is probably cooking the food that you're eating in those environments. And the challenge is that equipment is critical. If your stove goes down, if your oven goes down, you're not making pizzas. You're not being able to serve your customers, and you're losing money, and you're losing your customer value in those equations. And so what Welbilt did was they used Azure Sphere to go and connect all of this equipment that they have in these kitchens, so that they can accurately monitor and see the behavior of the equipment. Because the restaurants are able to leverage this information, they're able to do a lot of things. The most obvious, predictive maintenance. If I know when the system is starting to show some odd behavior, I can go and catch the issue early and resolve that early. I can do remote updates. One of the biggest things that happens for restaurants is that when there is a new recipe, when the burger chain goes and creates a new product, they have to go and send that recipe to all of the different stores. So to ensure that the equipment is operating in the right way for that solution. Normally, this is done by a USB key that has to go and then get physically installed into each one of these devices to perform the update. With Azure Sphere, because you are enabled with a global CDN that can deploy your applications and assets as part of the offering that you take from Azure Sphere, you are able to go and remotely push all of these updates to the devices wherever they are in the world. You can do fewer truck rolls. So that means a cost savings and faster fixes because you don't have to go and do unnecessary repairs and updates. You can figure out what's wrong with the equipment before you go there in order to get that information, because you're able to pull the telemetry from that device in a consistent and sustainable way so that you know that that is going to work right. You don't have to have somebody going and filling out a work order request form. It happens automatically. And really, one of the biggest things that, beyond the usual use cases of, saving time and money through these systems, is that companies are changing their operations as a result of this. They are able to improve the quality of their food, and they're able to reduce the chance of illness because they can monitor systems from start to end. They can tell, is the oven running at exactly the right temperatures that we have specified so that the food is cooked properly? Are we sure that the fridge was running properly and kept all the food cold the entire time? When it goes to the next stage and it's going to be sitting out there for cooking, are we getting the information so that when it's in the cold bar, did it actually ever get too hot for the environment? Did we create a risk of having some infection or some contaminant start to interface with the food? You can do all of that because now you have a system that you are able to pull that data from reliably and consistently, and you're ensure that you can do this because that system is secure and it can't be compromised. Let's go on to one more example here, and we'll talk about something that Microsoft has done as well. So the Microsoft data centers use Azure Sphere to connect and monitor all of the equipment that's running in that data center. When you think of critical infrastructure, think of the billions of dollars that Microsoft drives through the data centers. All of the Azure customers need to ensure that their systems are running properly and their workloads are running properly in the cloud. And the only way you can do that is to make sure that the electrical system, the air handling system, the power distribution systems, the networking environment is all running at peak efficiency. You can't do that in these areas that have previously been air-gapped. These are areas where, because these systems were so critical to the operation and the success of business for not just Microsoft, but also for all of our customers, that these things were never connected. With Azure Sphere, there's the trust and reliability in the system because we have thousands of engineers that are working and identifying CVEs and patches. There are red teams and constant threat assessments being done against the product to ensure that it is meeting the highest standards in security and that no vulnerability, there's no unauthorized access to the devices and the data that these systems are producing. And as a result of doing that with our data centers, we've been able to do things like the predictive maintenance you would expect. We know exactly how the systems are operating, so we can determine when we need to do work ahead of time so that we don't have downtimes and unexpected failures. We are able to improve operations because now that we know how the system is running, we can optimize for the hot and cold aisles in our data centers. We know exactly how to do this so that we can lower the operating cost. We don't need to run the cooling as efficiently or as actively if we're seeing that the systems aren't loaded in the same way. We can go and we can improve security because now we don't have to have people operating into this space. We can go and remotely deploy updates to these to our BMCs and other equipment because we're able to do this in a secure manner, and we don't need to have the sneaker net working and giving these updates. We don't need to have unauthorized access into the data centers for these areas. And we're able to drive connected solutions that help with employee safety because, again, we don't need to put people into these environments, and we're able to check and ensure that the systems are operating properly in the way we want to. The data centers are the most critical piece of infrastructure Microsoft has, and we built our systems to be able to support that environment. And so really, at the end of it, this comes down to why does, if you want to build a secure, connected device that you can trust to ensure you're getting the data you want out of it, Azure Sphere allows you to do that because it is all built in. You get to focus on your applications and differentiation instead of having to look at the basics of the platform. Leave that to us so you can do what you're best at. By bringing on innovations like the ML technologies that you saw for, Dave present, you're able to go and focus on development and make your solutions faster. So it's not just the work we do, it's the work our partners do that put this together. And now you're able to build complete ML solutions, start to finish, in a matter of minutes, instead of having to go and do this by building and bringing up an entire system and then making all of those other pieces work together to be a data scientist, a security expert, an OS expert, and do all those things. And then we're seeing this being used by customers in a broad range of activities that is helping them to both lower their cost and improve their operations. And we're seeing great success by this. We would be very encouraged to see you taking this step forward and also leveraging the Azure Sphere solution, connecting that system to Azure and driving that forward so that you can see the value and produce the transformation that you want to drive in your product and your business much more simply. Thank you for your time.
Thank you for joining us. I hope this has been as exciting for you as it is for us, and have a great day.